Hello and welcome to Live Code Stream, where we not only talk about programming, data science, and artificial intelligence, but we also code. I'm your host Juan, and today we're gonna be solving the Chief Hopper Challenge on HackerRank. So let's get started. Chief Hopper Challenge on HackerRank is categorized as a greedy challenge with a difficulty of hard. So let's jump into the problem statement to see what this problem is all about. ChiefBot is playing an all DOS-based game. There is a row of buildings of different heights arranged at each index along a number line. The bot starts at number 0 and a height of 0. You must determine the minimum energy the bot needs at the start so that he can jump on top of each building without his energy going below 0. So that's a very important statement. Units of height relate directly to units of energy. The bot's energy level is calculated as follows, and then they give us a formula for the new energy based out of the old energy plus the height of the bot. And this is what we're gonna care for now. They provide an example here with the different building heights, and let's try to analyze this example and how we can build a solution for it. So I'm gonna jump into Visual Studio Code to do the analysis. So we know our building heights, and we can copy, for example, this case that it's the sample provided by HackerRank. And what do we know? Well, we know that we want the minimum energy at the beginning. So we want the initial energy to be minimum. And what else we want? We want that the energy at any point of time, they call it the bot energy, it always needs to be greater or equal than 0. Because we want this energy to be minimum, that means that at the end, so we want to make sure is that at the end of the process, our energy ends to 0. Because if our energy at the end is 0, then we guarantee our minimum. So what we want is like our final energy should be equals to 0. So if we already know what we want at the end. We want our final energy to be 0. So the question is, can we go from the end all the way to the beginning? Well, that will depend on the function we need to implement to calculate the energy at each step. And in this case, our function is composed by 3 different calculations. So one calculation, let's create the calculation. So the first calculation is when the bot energy is less than the height. And when that happens, we say that our new energy is equal to our bot energy minus the height minus the bot energy. And then we have our case where our bot energy is equal than our height. And then we say that our new energy is equal to our bot energy plus the bot energy minus the height. And then we know that when the bot energy is equal to the height, nothing happens. So we can safely say that our new energy is gonna be equal to our bot energy. Awesome. So our function is deterministic, and it's a very simple function, and it can be easily reversed. So that's what we're gonna do. We're gonna reverse these 3 functions, or these 3 different equations. So this is just a simple math. So our new energy is gonna be to the bot energy plus minus the height plus the bot energy. So the minus sign affects both of them, and that gives us that our new energy is equal to 2 times our bot energy minus the height. So we want to know the bot energy, so we need to pass this height to the other side and then the 2. So our bot energy is going to be equal to our new energy plus the height, all divided by 2. So we need the brackets here, that's important. And then let's take a look to the second argument. So the second argument, we know the brackets in here. This is a plus sign, so the brackets are not relevant, so we can delete those. And then we have 2 times the baud energy minus the height, which is exactly the same line we have here, right? Or it's actually exactly the same we have here. So these two conditions are actually the same thing. Very interesting. So we can assume, or we can safely say, we can delete this condition, and we can say that when the baud energy is different than the height, we need to apply this formula, and when the baud energy is equal to the height, we can do this formula. But then this is something that gets really interesting. So if the baud energy is equal to the height, then we have that the baud energy, and when we know that the height is equal to the baud energy, so the baud energy minus the baud energy, so this is 0. So then we have that the new energy is equal to the baud energy. So we don't need a special condition for this. This formula, this calculation what we started with, it's already integrating this condition. So we can actually remove this, and we can work with a known unique condition. And this is our equation to move forward, and this is our equation to move backwards. So what do we need now? Well, we just simply need to call this function, and we need to go through the array in the reverse order, applying the reverse equation, and we're gonna get our initial energy. Awesome, let's jump into HackerRank. So this problem turned out to be more simple than I expected initially. I mean, I already did my evaluation and I found out that this is the proper way to solve it. At least this is the best way I found. You can tell me if you find something else, but I haven't actually coded it. So let's do that together. So we're gonna need some final energy equals to 0, and then we are gonna be working this function backwards. I don't wanna call it final energy because I'm gonna be affecting it on each step. I'm gonna call it my minimum energy. So it's my desired output. So my minimum energy is gonna be equal to 0. And then we know that we need to loop through the array of the heights of the buildings in reverse order. So we're gonna reverse our input parameter array. And then we know that our minimum energy, so our minimum energy, which is gonna be the baud energy in this case, is gonna be equals to the new energy, which is again my minimum energy, plus the height, all divided by 2. Now, if we go to the problem statement, we know that the energy is an integer. It's always an integer. So we need to round this. Now the problem with just rounding is that sometimes it may round down or sometimes may round up. And for this particular case, since we want to assure we always have enough energy, we're gonna always round up. So math_cil, and I'm gonna put the whole thing into that function, and then that's it. Now we just need to return our minimum energy, and if our coding was fine, we'll see the problem solved. So let's first run the code just to test with a few samples that this is working. Awesome. Let's now submit the code and see what happens. So far so good. And there you have it. All test cases successfully completed. Congratulations, you just solved the Chief Hopper challenge on HackerRank. I really hope that you enjoyed this video, and if you did, please like the video, subscribe to my channel. I'm gonna be regularly uploading new content. Thanks for watching. See you the next time.